Alright, another thing that we're going to need to do our graphing, we have to find our zeros of our polynomials. Now, a couple things dealing with zeros of polynomials. Zero is a couple things. I can write x equals some number, and that could be a zero, which is also known as a solution to that polynomial. Now, the other part of this is, if I get it to the point where I have x minus that number, that's just a factor. And if I use that number that I found and put it in an ordered pair with 0, now it's written as an x-intercept. So all the same information written in three different ways, giving us three different types of information, but all meaning the same thing. They're the zeros of a polynomial. Now, big thing with the zeros, all it means is we're factoring. So let's take a look at a problem here. So we're going to start out with f of x equals negative 2x to the fourth power plus 2x squared. So to find the zeros, we're just going to factor. And we've done a lot of factoring, so hopefully you're getting more comfortable with it. This one, let's just do a greatest common factor of negative 2x squared. And that's going to leave us with, do this division, and I'm left with x squared. Do this division, and I'm left with negative 1. Now, since this is a monomial, one term, I can leave this one. But this one, x squared minus 1, it's one of our special factors that we can simplify another step. So in this case, we get negative 2x squared, and this is going to turn into x plus 1 and x minus 1. So now it's completely factored. So if I want to find the zeros, I'm actually taking my whole function and turning it equal to 0. So this is what I'm finding. Oops, that's ugly. Let's go back a step here and see if we can clean this up a little. So x plus 1, x minus 1. So for this multiplication problem on the right to be 0, we know that each of those parts has to be set equal to 0, because 1 or more than 1 could be 0 and make this true. So if we solve this, I can divide by negative 2 and find my square root, and I'm still going to get x equals 0 for this one. Here I can subtract 1 and get x equals negative 1. Here I can add 1 and get x equals 1. So when we're looking at this, in this step here, we've got our factors. Here we set it equal to 0, and we just found our zeros or our solutions. So for this particular problem, there's three different places where we could write our x-intercepts. In this case, 0, 0, negative 1, 0, and 1, 0. So this line gives us one set of information. Here's another. Here's another. It just depends on how they're asking the question, whether they want factors, zeros, or x-intercepts. So not too tough to deal with there, as long as you're comfortable dealing with our factoring. Alright, now there is another thing that we have to run into here, and it does have a big effect on some of our graphs, and that's the idea of multiplicity. And all multiplicity is something like if I went through and done my factoring, and maybe I ended up getting x minus 3 all raised to the fourth power. What that's going to tell me is if I were to set this thing equal to 0, it's the same as saying x minus 3 times x minus 3 times x minus 3 times x minus 3, kind of monotonous. And if I set it equal to 0, it means either this one's equal to 0, this one's equal to 0, this one's equal to 0, or this one's equal to 0. Well, obviously we're going to get the same answer for all of them. We're going to get x equals 3. So instead of writing x equals 3 4 times, we just say that x equals 3 multiplicity 4. Now there's a few things that are going to happen with this, but for the time being, this is just how we would name it. Now obviously a couple things are going to happen. Either this value up here is going to be even or it's going to be odd. So let's say we take this back and let's just give it some generics. X minus a all to the k power. If this happens, we're going to say that x equals a multiplicity k, and then a few things happen with k. Let's say it's even. If k is even, we're actually going to do what I like to say, touch and turn. So if you think of a second power, something comes down, it touches, and it turns because it's a parabola. Fourth power, same thing. And it could come down and up, it can come up and down. So if it's an even multiplicity, it's kind of going to be doing this at our x-intercept. Now the other option is if that value is odd. If it's odd, it's going to cross. So it could be one that crosses straight line, multiplicity 1. If it's third power, it could come up, turn like this. If it's fifth power, it gets steeper and flatter, and so on. So what's happening is there is our x-intercept. So it's either touching and turning if it's even. If it's odd, it's either going straight through if it's first power. If it's third power, fifth power, seventh power, and so on, it's going to touch, turn, and keep going. But it will cross. So even powers will touch the x-axis but not go through them. Odd powers will touch and go through, whether it's a straight line, first degree, or if it's a higher degree of an odd power where it's going to have a little bit of that curve to it. So again, think first power, second power, third power, and so on. And that'll set you up for multiplicity and how it affects your graphs.